So let's have a little definition of mathematics, okay? Because we hearing that word a lot. You can even Google it. What is the meaning of mathematics? You might get different definitions. So this definition there is my definition. Mathematics. I consider mathematics to be a language. All right. If you want, you can Google right now what is the meaning of a language. You normally use that word every day, but sometimes we take it for granted. What is the formal definition of a language? What is a language? Mathematics for me can be considered a language that we use to convert words into symbols, and that happens a lot in maths, converting words to symbols. And if you're aware of that constantly, you might start to understand things in a different way. Words to symbols, that is very prevalent in mathematics, the conversion of words to symbols, concepts into diagrams, okay? A world phenomenon into a diagram, a graph, all right? A pie chart, a bar chart, concepts into diagrams and graphs to facilitate numerical and objective analysis. Okay. Here you can view mathematics in terms of a process. So first you start with the real. Okay. For example, you may see that in a real setting. I'm not saying nothing yet. I'm just telling that picture that you see. And then these words now will come in your mind. Words like nest, 4, eggs, 3. So these words will pop up on your mind based on the language that you speak. This is English, so these are the words. If you're a French person, same thing, but different words for that same image. Japan, different words for that same image. Then you have 4 eggs and 4 eggs and 3 eggs is equal to 11 eggs. So when we view reality, there are two main things that we do. We qualify and we quantify. Brown, shine in. Then we start to count. 1, 2, 3, 4. So these two things are automatically ingrained, inherited in our way that we perceive our environment. Then we have to try to communicate what we see. Written, words written. Then we may create symbols to indicate 4. 1, 2, 3, 4 may use strokes. And 1, 2, 3, 4, 1, 2, 3, 1, 2, 4, up to 11. Then you have a different symbol because this is too cumbersome for this is a symbol that we know for 4. This symbol was invented in India, okay? And this is the symbol for and, because and in Latin is et. So this is an abbreviation of et for and is like 8. In English, you say and, but in Latin, you say it. I think Spanish, no, French say et too. And in French is et, right? Toi et deux. Yeah, so and in French is also et. Okay, and that's the abbreviation for et. 4 and 4 and 3 is equal to 11. Is equal has a sign. 8, you see that T that is here, that is the abbreviation for the plus, you know, that's where the plus come out, you know. The T in ET, you know, that's where the plus come out. That's our symbol. So you can see now from words, from the real to words to symbols. So when we look at this, we say, well, mathematics. When we look at this, we will not say mathematics. It's in a bunch of words. But when we look at this, we'll say mathematics. But the information this is saying, modern times, a whole set of symbols, and the information this is saying, it's the same. 4 eggs and 4 eggs and 3 eggs is equal to 11 eggs. Okay? So the mathematics is just translating from words to symbols. So that's why one of the main reasons I'm considering math a language. And the whole idea is to convey information, to communicate more efficiently. Look at how this is reduced. And look at how you have all those words. Okay? So always bear that in mind. That is what is actually happening when you go in a math class and you see all those symbols. All those symbols now are just words abbreviated. All right? each symbol represents something, a potential something in the real. Okay. You may have another example. So why do I have to do mathematics? Look at what Sir may respond. You may open a business called the Barber Shop and Beauty Salon. All right, you open a business in your community, in Roseau, wherever you are, and you say the Barber Shop and Beauty Salon. Over here, cutting and beautify. Words you might say in your mind. I need to record my revenue, every day, so that I can have an idea of how much I'm going to make the following day. So you want to see the trend of your revenue. Then you're going to create a diagram, a table, and you're going to start to record. Day 1, you make $2,000. Day 2, you make $4,000. Day 3, you make $6,000. That's just an example, and that's what is happening in the real. Then now, from that information, you can abstract this calculation, revenue divided by this, dollar over D. You get 4 minus 2, 4 minus 2 over 2 minus 1, you get 2. So you realize your revenue increasing by 2 every day. So you can predict that in day 4, you may make $8,000, so then you can plan. So that is the use of mathematics, it's a language that we use to make things more efficient, okay? And you can plan and predict, and it's the same words turned into symbols, every symbol there is a word in, O-N-E, T-W-O, T-H-R-E, representing a quantity of a real thing, okay? So that's why now you can say every symbol you see in an equation represents a potential real-life variable. The entire equation sets out to describe the relationship between them in a real-world phenomenon. However, very commonly you will see them as X and Y. So when you go in a math class, you see a whole bunch of X and Y. But really and truly, the X now is a symbol used to represent something in the real. So most times in our math class, as mathematicians, I monitor not every time when you come in the math class and we start to do X and Y. We're starting with these symbols and we're trying to expect to apply to the real. But really and truly is the reverse. It's starting with the real first, and then you have the symbols created, because the symbols is an abbreviation for what happened in the real, you see? And also you can say mathematics can also be viewed as a tool, a mechanism or language that we use to communicate ideas dealing with computation. So instead of writing all those words in a paragraph, you just create some symbols and it is reduced to create efficiency of communicating ideas, okay? And just to reiterate, first, you start with what you objectively perceive. What you see, hear, smell, taste, feel, okay? Using your 5 senses, then you have an image in your mind, okay? And words, you're saying you're thinking, because when you think, we think in words. And you may want to document, so you convert those words to diagrams and symbols to facilitate documentation and written communication of ideas involving numbers, involving computation, okay? Because we automatically qualify and quantify. Like it or not, anytime you analyze something, automatically you quantifying, okay? But the thing about the quantification now, it is more or less revealed when you start to document. But most time we into verbal communication, so we don't normally express the quantification part, and we normally dwell most likely in the qualitative part of analysis, okay? But the quantitative part is there, probably suppressed a lot of times. But if you want to become a professional, you cannot be qualitative all the time. You cannot be an accountant and only words alone, you cannot be, not even a psychologist and only words. You must have some numbers, you must quantify. And also we have a situation with COVID and so forth. What about the numbers? How many? What percentage? And so forth, so that you can make decisions using information. All right. And here we can reiterate the process of mathematics. Mathematics brings to the table this process. We can look at the process. What process are we talking about? It first starting before we perceive what we see. If you look around you, look at some books there. As I watch in the books, I count in 1, 2, 3. Looking at the color, so we qualify and quantify. Here the word one, O-N-E. Then we create a symbol for one, T-W-O, a symbol for it. So you're seeing and you're hearing, you're smelling, tasting, you're feeling, and you're intuiting, using your sixth sense, as they say, perceiving reality. Now, when you do that, now, when you see, you hear, you smell, words come in your mind. What are you hearing? What are you seeing? Using words, depending on the language that you speak. If you in English, here we speak in English, so we think in English. A book, B-O-O-K. If you're in Spanish, you say libro in your mind. Live in French. In Japan, you will say book in Japan. According to the native language, that's what you'll be saying in your mind, using the words. Qualitatively, colors and so forth, texture, and quantitatively, how much, or it cost, and so forth. And then to socialize now requires spoken and written language. So now your qualitative reasoning is writing using words, okay, a brown book and so forth. Quantitative reasoning now translate those words using symbols, mathematical symbols. Okay, so that's why maths can be viewed as a language, you see, translation from words to symbol. And specifically here now, we are doing statistics, okay? Now the statistics now, it can be viewed as a process. You first start in a research topic, a research question. What is the research question? It is the fundamental initiator of the research. It is the one that should be answered by first collecting data, and there will be variability in that data. The research project sets out to answer the research question. So you have a research topic, and then you ask a research question, and then you have a hypothesis, which is a supposition or proposed explanation, a statement or sentence, if you will, made on the basis of limited evidence as a starting point for further investigation. In other words, it is a possible answer to the research question with little or no empirical evidence. So you have a topic, then you have a research question. For example, college students, that's your topic. You have a research question. I wonder, what is the average height of college students? That's a research question. And then you have a hypothesis, a possible answer. Oh, college, the average height of college student is 5.5 feet. So you just off your head a supposed possible hypothetical, you understand, hypothesis, a hypothetical answer. You see the words rhyme? Hypothesis, a hypothetical answer without evidence. Then to verify that hypothetical answer, to see if it is true or not, then you have to go to collect data now, using questionnaires. So here you have the process of statistics happening. After you collect the data, you have to organize it, because the data now comes disorganized in a raw form. Tables. Then you have to represent the data, because a picture worth 1,000 words literally. If you want to communicate a tree to a crowd that have all different languages, from Aborigines to Eskimos to Japanese to tribes of Africa, each of them speaking different languages, and you have a whole crowd of that, and you want to say the word tree. You know how much words translation you have to do. All you have to do is just draw a tree and just show it to them, and everybody will know it's tree that is in your mind just by seeing the diagram. So literally, a picture is worth 1,000 words. So that's why you need diagrams in statistics. And not only statistics, you never see a textbook without diagrams. Okay, the power of communicating information, very powerful tool to communicate information. So that's called a representation of data. Then you have the analysis of the data, calculation of mean, median, mode, standard deviation, and so forth. You're numerically analyzing the data. And all of that now is to make a decision that is based on information that you collected, conclusion based on information, to verify whether that hypothesis that you stipulated at first, if it is true or not. Okay, and this process from research topic, research question, hypothesis, collect data, organize data, represent data, analyze data, and to make informed decision, you can get that in any program. That's why all programs from college to university you must do statistics. It could be from engineering to psychology to biology to chemistry to economics, because now at one point in time, even for your thesis, you will be collecting data. So you will be making a research. So that is why you are in this course, in this class, PAF 121B, so that you can gain the skills to complete a research project. Okay.